Good afternoon. Everybody awake? Excellent. All right, so before I begin, I wanted to go ahead and go over just a couple of things in general for those that may be new in programming. This particular talk, I'm going to do my best to keep it low level. For the most part, I don't want to scare you off. There are a lot of things that kind of come with time, and I really believe in general that learning to program is kind of like learning a language, such as Spanish or French. It is extremely important that even if the concept may be foreign to you or you may not understand everything, that you be exposed to it. So just like if you want to learn a new language, they say, some people tend to say, I should say, that if you go to that country and you immerse yourself, you tend to learn faster. Programming is very similar to that. If you hang around programmers, you listen to the way they speak, you listen to the topics they talk about, you tend to absorb it. So towards the end of this talk, I will be going over some general code. If that is above you at this point in time, that's okay. Please do not tune out. It is still important for you to kind of be exposed to terminology, to syntax, even if you may not understand it all just yet. Also, this particular talk, I've been thinking about here recently because a lot of people have been asking me how to get involved in programming. And like Kimberly said, I had really dug into the free Code Camp curriculum early on several years ago, and it helped me out tremendously. And then as I grew as a developer, I wanted to give back in the best way that I could. And this is kind of my opportunity to do that. One of your first questions outside of, or one of the most common questions outside of what do you do for a living, what is programming, do you just sit in a cubicle all day and work, does it involve math? Is it hard? Do I need a degree? Those tend to be the most common questions. No, very typically, if you can add, subtract, multiply, and divide, you're pretty set on math. And even if you can't, if you're good at Googling and you can learn on the fly, you should be fine. I happen to be fairly lucky in that my previous degree involved some math. I was exposed to it. I've forgotten almost all of it. So my Calc 2 teacher would be extremely disappointed in me now because I could not tell you anything about it. Most of my job these days involves multiplication, division, and then the quirks of whatever programming language I happen to be using at the time. So let's go ahead and begin. The topic of this talk is how to think like a programmer, specifically in JavaScript. I think the curriculum in Free Code Camp is still very JavaScript oriented. They might have some new Python stuff coming up. For the most part, it's still JavaScript. And JavaScript tends to be the easiest language to get your foot in the door whenever you want to be a programmer and you don't have a traditional bachelor's degree or master's degree in computer science because you'll be working in the front end, and the front end is JavaScript. My name is Daniel Ashcraft. I own a very small web and software development company called Avast and Fire. And it's very fun. It's interesting being on the other side of this because I get to do interviews now and I get to listen to people have the same problems I had whenever I went and did interviews. And I remember very vividly, late 2014, early 2015, getting my first technical interview, and I bombed so hard. I think I was given a very classic FizzBuzz example, and if you haven't heard of that yet, you will at some point in time. I failed it. I failed it so hard. They gave me the job. So it was an interesting day. I learned a lot that day. I only have an associate's degree, and it's not in computer science. So you can do it. I promise you. Also, quick side note, if you are in a underrepresented minority in technology, we need you so badly. Right now, there's a huge silo of perspective in tech. So if you come from an underrepresented background, please, please, please get into technology. A lot of times when you approach a problem, you bring your experiences and your life and your culture along with it, and it helps to influence how technology and websites and marketing and advertisement and products are created and made. And obviously, if you don't want everything to be kind of siloed from one perspective, you got to get involved. So if you have any questions related to that, please let us know. We'll do our best to help you out as well. All right. The what and the why of this talk. As developers, our jobs in general are to solve problems using code, experience, our fellow programmers, and the internet. By the internet, I usually mean Google and Stack Overflow. If you haven't heard of Stack Overflow, you will. At some point in time, you will Google, how do I do a thing, and insert X programming language, and it will usually pop up Stack Overflow. If you see answers that get upvoted, those tend to be the best answers. Sometimes they can be a little bit complicated. That's okay. The second part is there are tactics that, as a beginner or junior level developer, you can employ to help solve problems faster and with more efficiency. As I stated, I failed my first code interview, my first technical interview, I should say, but I ended up getting the job. So a lot of times whenever you do the more technical stuff and you're sitting in front of somebody programming, they want to see how you think, not necessarily whether or not you can solve the problem or if you can be the most efficient at solving the problem. Sometimes that's the case, but a lot of times it's not. There is a vast difference between open jobs and available developers right now. So trust me, if you can show some competency and the ability to learn on the fly and be confident, you have a high likelihood of getting in fairly quickly to your first job. You just have to apply yourself and get in there and get it done. All right, I'll go back real quick. This one is kind of important. I don't see this very often in slides, but we solve problems using our fellow programmers as well. Free Code Camp does a good job of kind of getting you to think like this off the bat. One of their first challenges they have you do, they tell you to try to solve it yourself, try to Google the answer, search for the answer on your own, and when in doubt, go look at our forums where we have other programmers, we have other people that you can talk to. You may not have approached or seen a particular problem before. Odds are somebody else has. A lot of problems that we have going on in our programming world has been solved by somebody before. You just need to kind of put your feelers out and see if you can't find the answer, or at least get a good sense of the direction of which way to go. So I also want to separate out real-world examples from contrived examples. So in the real world as programmers, we don't tend to get a lot of high-level math problems unless you happen to be working in an industry that is heavy in math. We tend to get a lot of problems that are more, they involve a lot more creative problem solving than they do just rote memorization. And by that I mean the math part. A lot of times the contrived examples are going to be heavy in math. You're going to see things like, count how many unique X's you can find in a string. It's not exactly super useful in the real world. Not a lot of people are going to sit down and pay you to go find unique X's in a string. There are those 1% of jobs out there where you do that. Odds are your first job won't be one of those. But real world examples are kind of important. You have to practice the contrived examples because at some point you're going to be asked a question you may not have any, why would I ever want to do this? Once again, think of it like this. They want to see how you think, not necessarily whether you solve the problem. And they also want to see if you kind of approach the solution in the correct way. There are definitely wrong ways to approach the solution, and there are better ways to approach a solution. So once again, it kind of goes back to the interview portion of it. Fizz buzz. Oh Lord, here we go. So I will do my best to go over the differences between those two kinds of problems, and I'm going to present two kinds of problems towards the end that will involve code. Don't tune out. There are legitimate differences between the two. So how to think. The first step is know your programming language. This one is kind of an interesting one. Depending on your level of ability in a particular programming language will dictate how you go about solving a programming problem. If you've only ever done for loops, or you've only ever used higher order functions, that's probably how you're going to solve the problem. Do not, as you're going through these interviews and these processes, try to, especially if you're being graded or judged for it, solve the problem with tools you don't know. Also, the more you know your programming language, the more tricks you can kind of have up your sleeve, the more times you've seen a particular problem, and you can then employ the solution a little bit faster, such as knowing what a set is in JavaScript. Very rarely used, but it kind of picks out only the unique values in an array. I could think of a million ways to use that, but if you've never heard of that, if you're not proficient to that degree with JavaScript, you're not going to be using that in a solution. And definitely don't try when you're in the middle of solving a timed problem or something similar to that. Use what you know. I was recently talking to a friend of mine. He says, I don't understand I said, well, think of it kind of like the Stone Age, the Bronze Age, and the Industrial Revolution. If you're living in the Stone Age, you're going to use stones to solve your problem. It's just a reality, and that's okay. You can still solve problems with stones. In the Bronze Age, you're going to use bronze swords instead of stone tools because they last longer, they're more durable, they're more efficient. Code can be flexible, it can be durable, and it can be efficient. So that's just an idea of use the tools you have available based on your proficiency in a given language. Hey, look, did you know you can turn a string into an array of characters by using the spread operator in ES6? If you're not super high proficiency in JavaScript, it might be a foreign concept to you. If you've never seen JavaScript before, it's definitely a foreign concept to you. So that's just an example. Use the tools you have. Here are just some general tips of solving problems. And like I said, I failed my first technical interview. I know I did. They told me after the fact. I didn't get the answer. It did not work. I am notoriously bad at solving complicated kind of rote memorization problems because it's just not very fun for me. It's hard for me to motivate myself to practice it. I'm lucky now that as you get further along in your career, you can kind of be a little more picky and choosy about the interviews that you do and try to get them to be the best interviews for you in certain, to a certain extent. You still have to be familiar with the programming language. The first step is don't overthink it. A lot of times, whenever you look at a problem, you try to think around the problem. Read the words that it gives you. It's like whenever you're given an English exam over the concept of a prose, or the main elements of a story. You have to literally read the words. It's okay. If they don't say something, try not to infer it. If they don't tell you you can't do it, you might try it. If they tell you don't do something, definitely don't do that thing. So the big deal is don't overthink it. Solve it first in particular. Don't worry about elegant code. If you are only proficient in for loops, don't try to use a map or reduce function. Use a for loop. That's okay. I personally have an aversion to for loops. I will use a for loop if I have to, and recently I had an example where I had to use a for loop. It was faster. It just was. So I use a for loop. But whenever you're going through this and you don't know a lot of the other built-in functions or operators or some of the quirks of your programming language, use what you know. Don't worry about elegant code. As you get further along in your career, you will know kind of the more elegant solution by default because you will have seen that problem 100 times and you will know kind of the shortcuts. So it's not that you don't have those tools in your arsenal of problem-solving skills, it's that you just happen to know which tool to grab first and you're a little further along. The third little tip is solve it the easiest way first. Sometimes, and I don't see this too often with people who are self-taught because you haven't been exposed to some of these concepts, higher level concepts like optimization and speed and efficiency and readability before. But sometimes people that come out of a university degree program have this problem. And they try to solve it the most optimized way first. It tends to be the most difficult, and when edge cases occur, you don't account for something, it breaks, and you don't know where it broke at. Solve it the easiest way first, then double back and optimize. And that's only if you can. If you can't, but the solution works, and that's as far as you can go, that's okay. You do not have to go overboard with optimization. You don't have to, for the most part, on your first, second, third, fourth jobs, need to know how fast something is. And I will go over some tools to let you know where speed and efficiency kind of come into play, specifically with JavaScript. And like I said, don't tune out. Here's an example of something that came across my desk last week. I got paid to solve this problem. You will be paid to solve similar problems to this once you become a developer. Good morning. You've been assigned ticket number 1312. We need to be able to find a company by name from an array of companies. I've solved similar problems to this all the time. This would be equivalent to having a search bar and a drop-down, right? Like you have a list of food items and you only want to choose foods that have dairy in them or don't have dairy in them. It's a very common problem. Do this, filter this, we'll pay you for an hour, you get paid for an hour, make lots of money, go home, be happy. This is not involving a modulus operator. I do not have to divide by some contrived number. I don't have to solve for the 14th digit of pi. I just need to make sure that I find the name and I return whatever object has that name. That's it. No math really involved in this problem. Contrived example. Palindrome. Check to see if a string such as ABCBA or ABCCBA or palindromes. If you're not familiar with palindromes, it means they're the same forwards and backwards. So like taco cat, race car. It's a very common kind of programming challenge. And sometimes the difficulty in these are the extra things they tack onto it, such as you should account for odd numbered letters, such as ABCBA. Obviously, the C is odd, so you have to go up to C, and then you got to go from the end back to C. Very interesting. This one involves some math, because you're going to have a different answer for the even solution. You have a different answer for the odd solution. There are a million ways to solve this problem. They are all, for the most part, right. Some are better. Some are better in terms of speed. Some are better in terms of efficiency. And some are better in terms of readability and like overall extensibility. If you write a function that nobody can understand, it's probably a terrible function. It may sit out in production for 100 years, but it's only sitting there because nobody wants to touch it. And if they did, it might break everything. That's not really the code we want to write as developers. Sometimes you're going to get painted into a corner, and you're going to do that. But for the most part, we want to write programs and functions that other people can come on after us and extend, write, have it solve another case, know how to use it. I've seen functions in the wild, like Pokemon, that nobody knew how to use. It was used in one particular place, but reading the code, you didn't know what it did. It just happened to solve one particular problem in one way. There may have been other scenarios where we could have used that function, but nobody could really understand it. You will see code like this on Stack Overflow, where they're trying to solve for the fastest possible answer, like solve this in 1/100th of a millisecond. And there are people out there that kind of thrive on that. For the most part, you don't want to write code like this. You just don't, unless you're YouTube and you're like analyzing a million bits of data because it becomes important. But for what we do on an everyday basis, it's not tremendously important. There's a threshold for general browser response times that we can stay within, and you're going to have a really good answer. And you also have to think in the future. This list has 10 items now, but what if it has 100? That's about it. Now we're going to talk about some code concepts. We're going to talk about your two most powerful data structures for solving problems. They are not the only data structures. They are not the data structures, for the most part, that you're going to, well, there are two of the data structures you'll learn out of a plethora of data structures in college. But these two come up extremely often. If you attempt to use these particular data structures, 75% of the time, you're going to be well off. These are specific to JavaScript, but you can also write them in other languages. They are not only in JavaScript. Most languages have arrays. Most languages, you can create a hash map. I'm going to show you code now. Take a deep breath. If I can exit my slides, that is. All right. So here it is. I'm going to blow this up. And just to make sure everybody can see this, can everybody see this okay? All right. So, arrays are just a list of items. It can be a list of anything. The higher you go up in your ability and your comfortability with JavaScript, the more you will be able to leverage these in very unique ways, such as JavaScript is highly optimized. It tries to assume things. If you write it an array and it knows that all the values are strings, when it compiles, it will use a completely different compiler or transformation protocol to optimize to solve for strings. If you mix strings, numbers, and objects, it will not do that. You don't need to know that. It's just something that you learn as you go. In this particular example, I just went ahead and identified it by index. So, JavaScript, like many programming languages, are zero-based. So it starts at 0 for the first of the index, and the second one would be the first one. So it just shift it all by 1, and that's the index. So if I call index 0, it's going to return 0. If I call index 0 now, right, it'll just return Daniel, right? If I return 1, it'll return 1. Arrays are interesting. There's many ways to sort an array, and there's a lot of value in using them whenever you cannot find a quote-unquote unique identifier, such as a list of characters. Arrays are very useful. There are times when it's not the best, and that usually comes when you don't know the index and you could make a unique identifier. What I mean by that is, if you can identify whatever data is coming in, and there is one thing that is unique to a piece of data always, you can usually use that as a key. So there are several programming languages that implement this in interesting ways. But what you should think about to kind of remove the programming from it is that if you could reach your hand into box 3, that's really fast, right? So instead of telling me to go grab an apple, just tell me to go to box 3 and pull whatever's out. You don't need to know that it's an apple because you know it's in box 3. Now, if somebody says, hey, go through all of the boxes and find me the apple, obviously it's a lot slower, right? And that's where arrays kind of become an issue, is whenever you have to go through each one and see what's inside to check if it's what you need. Now, another way to do this is called a hash map. Hash maps are a very powerful data structure, and they tend to be very, very fast. This is an example where the key is the number of the box. So in this particular example, if they said go to the box that's got the label 3 on it and just pull it out, you could do that. You could walk up to the box, you could pull it out. You don't have to look at any of the other boxes. It is very fast. This is useful for whenever you're going to organize data in interesting ways. So think about all the ways where we have like a unique key in the real world. Ranks on a leaderboard. Yes, ma'am. That is a great question. So a hash map is a key value store where the key is unique and the value can be whatever you want. An object, the key could be anything and it could go to a function. The key has to be unique, and that's in both cases. That is correct. Otherwise, it will overwrite and you're going to get some weird. Nope, that is fantastic. They are identical in that respect. No, fantastic question, Carmen. So if this was an object, we could do something like add, and we could have a function here that just returned whatever we want. So it doesn't have to be values. It could be something like a function, which is really unique. But hash maps are super, super useful. Once again, going back to an example, a leaderboard, like a first place, second place, third place, fourth place, that's an example of a hash map in the real world where you could have 2 people tied for second place. So instead of looping through everything and checking which one is where, you can just go to second place and pull the 2 people. You don't have to loop through everything. You don't have to go through each value and check them. So that's an interesting example of a real world scenario. Or you go to a farmer's market and there are buckets, and each bucket is labeled apples, oranges, etc. They're not just all jumbled together where you have to go through each one and then pick out the oranges and the apples. They are identified by something unique. Apples are going to be an apples bucket, etc. So obviously, arrays are just a tiny bit slower in some instances than hash maps. specifically when you don't know the exact index of what you're looking for. Hash maps are not very useful if you don't have a unique identifier, because you cannot use them. You're going to have conflicts. So we're going to go back and drop the code a little bit. I hope I didn't lose anybody during that. But if you are not familiar with those two concepts, specifically those two data structures, array and hash maps, go and play around with them. They're super useful, and a lot of things you can do with both, which hopefully we get some examples. All right. Oh, great. We got more demonstration. Before I begin on some coding demonstrations, because those contrived and real-world examples I'm about to actually go through and do with code, I want to go ahead and answer questions, because although I advised everyone not to tune out, someone will inevitably tune out. I want to catch you before you do to answer any questions you might have, just to keep that from happening. So I'll answer a handful of questions real quick before I get deep into, well, not really deep, but show you some examples of code. Any questions? Sure. Do we all know JavaScript? Raise your hand if you know JavaScript in this meetup. What? A little bit? JavaScript meetup? Oh, okay. All right. So the first example this is a first real world example, which is, we have some companies in a list. Most of the time, whenever you're given data like companies or specifically from a database, it will have a unique identifier. I went ahead and put them in an array because a lot of times whenever you get data back from an API, whenever you get data back from a database, it's going to be by default an array. It's not going to be a hash map. Now, you could transform this into a hash map if you wanted to. Whole other story. So this is a real-world example. I'm not saying that the names are identical to what I solved the other day, because I can't have you going and taking my job. I can't have you submit the same solution for half the price. That wouldn't be very fair. Yeah. I know some of, people that know JavaScript in here is going to be like, man, this guy. Especially Chris over there with his fancy college degree. Call out? Okay. So we get an array back with ID 1, 2, and 3. And they got company names. And your boss comes and says, we want to pay you X amount of dollars per hour. Please just go and solve this problem so that our users can quickly find, this particular company. This is an example of, solving it using a for loop. This is a for of loop, which is like a foreign loop. They use the term of. I'm going to pull each object off of the array. I'm going to check if that company name is equal to the name we passed into the function. This one is interesting, 2 lowercase. Whenever you're first going through some programs and some problem-solving situations, there's a term you're going to come across called edge cases. And this usually revolves around null values and malformed data to a certain extent. But that's a little bit different. In this particular instance, if they pass in a capital A versus a lowercase a for Acme, we still want to pull back Acme. Not everybody is going to hold shift and hit the A when they're searching for something. And also, sometimes somebody might have entered the data in wrong for the database and it may have a lowercase a. We still want them to get back the correct example. So I went ahead and turned this into a lowercase string by default, both the input and the result coming back from the database to check against, because if I lowercase both and they're both lowercase, they're going to be identical no matter what, right? Because if I have a lowercase a and a lowercase a, even if I pass in an uppercase, it's going to get transformed into a lowercase. They're going to be the same. In this case, I just loop over every value because it's an array. I don't have any unique key to just go and pick off. And then I check to see if they exist. And if it does, I return that company from the function. And if I pull this off, I can actually use a different example real quick. Right. It returned the object that matched. And of course, if I go back and I lowercase this, it'll still work. All right, so that's an example of using a for of loop. When you first get started using JavaScript and you're going through some problems, you're going to use for loops. They're one of the first kind of looping functions you get from a programming language, and they're some of the most important because in the background, everything for the most part uses a kind of for loop. You just don't know it. There's some syntactic sugar on top of it. They changed the name of it, make it easier to use, like put it in a more common paradigm, give it a better name. As for, kind of iffy, but find makes sense. In this particular example, this is how, whenever you're first solving a problem, you may approach this particular problem. You're going to use a for of loop. You can use a typical for loop. You could even use a do while loop. But this is going to be something that's pretty standard. As you get more proficient, you may use find. Right? And in this particular instance, this is doing something very, very similar. I'm saying loop over, and whenever this is true, just return what was true. As you progress in your ability with JavaScript and you want to really improve readability, the word find may be easier for someone to extend than a for of loop, if you can use it. I'm not saying it's the only way, but if you can, and it's going to be efficient for the problem, try to. There's find index, which can be useful if you want to know the index of what you're looking for and just kind of pluck it out. There's map, there's reduce, there's sort, there's filter. There are a lot of pre-built functions and methods on these data types that will really help you solve these problems. But you can still use the for loop, the very first thing you will learn in most programming languages. You do not have to know that find even exists to solve the problem. It's not a requirement. So in this particular instance, it does the exact same thing. It's just a little bit more, it's a little bit less verbose, and it makes a little bit more sense in terms of the verbiage it uses. All right, and now is the palindrome one. I already see a modulus. This one involves math. Please don't check out. It's okay. Palindromes are interesting. Palindromes are kind of like in most programming challenges to some extent will have kind of a brain teaser element to them. So if you like solving Sudoku puzzles and stuff, and that's like something you enjoy doing, you might be very good at this. I am terrible at Sudoku. I don't know if I've ever solved one without my wife's help. And by my wife's help, I mean she does them all, and then I guess. And like I said, I failed my first technical interview with a FizzBuzz challenge. Not my strong suit. As I've gotten better and I've learned a lot more tricks, and I have a lot more tricks up my sleeve to be able to put these things into kind of a story I understand. In this particular instance, because I've solved this problem before, I know that if it's an even, lettered string, if the length of the string is even versus odd, there are some things I can do to make it better. I'm going to go ahead and walk through this code just a little bit, and I actually have an example both in a for loop, which is how you would solve it out of the gate, and then I have an example using a more advanced solution, a more advanced technique for those of you that are more further along. Once again, right tools for the job, the problem still gets solved. It's preference and then also readability. In this particular instance, I have a function that does a thing. The first thing it does is it spreads the string. This is that kind of interesting thing I said earlier, where you can take a string and you can make an array of its letters just by using the spread operator. Spread operator, super useful. It's useful in a lot of ways. This happens to be one of the nifty tricks I have in my bag when dealing with strings, and I want to just make an array of characters. There's also toChar and char@. There's also a split operator. There's many operators that do this. This is the one I happen to choose. I also cast it to lowercase, because if they put a capital and where there's no lowercase, I just want to go ahead and make everything one kind of uniform rule, so to speak. Here's the math part. Modulus 2. I believe, and somebody can correct me on this because once again, my modulus operator verbiage is terrible. I believe that's identical to the remainder when you divide. So If I have 3 and I divide by 3 and there's no remainder, it means it was divisible by 3, I believe. I got a nod in the head. Yes. Calculus professor, be proud. So in this particular instance, I'm just going to check and see if it's divisible by 2, because once again, A, B, C, C, B, A is different from A, B, C, B, A, right? Because I have to go to the middle, separate them, so they're going to have 2 different ways of solving that particular problem. I can put them all into one. I chose not to because of 1, readability, and for 2, if you try to solve all cases at once, when there's a clear division, you're going to get confused. It's very, very possible that you have a for loop with a lot of checks, and one of them will break and you won't know why or where, and that will make it a lot more difficult. So whenever there's a clear division between 2 ways of solving the problem, try to split them up if you can. If you're super awesome and you want to write a 1-line function that does all the things and it does it super fast, that's awesome for you. I'm not at that in my career yet. So I chose 2 separate functions. I literally just pass it into the function for check even and check odd. They have very similar structures. I'll start at check even real quick. It's a for loop. That's it. It's not even the best for loop for this, but it worked. And I was able to do it in like 5 or 10 minutes. I solved this problem in 5 or 10 minutes. It got me past the leak code palindrome problem. That's awesome. It's not the most efficient. I'm sure there's a million ways to write this better. But this is the way I chose for using a for loop. In this particular example, I don't think I even have to divide by 2 here, but we're gonna pretend you have to. I'm gonna shake my head. I'm gonna nod. All right, so we're gonna loop over all the items up to the middle, and then we're gonna check forward and backwards. And this part right here is the most kind of complicated part of this. And this is just me starting at the end of the array, the beginning and the end of the array, and working towards the middle. There's a reason. Arrays are 10 items long. And if you go through each one by one, it's slow. So it's useful when you're looking at these problems to identify removing some of those items if you can, or trying to do 2 things at once. It's easier to check 3 values than it is to check 10 values in an array, and it's faster, right? If you can kind of eliminate as many of those buckets as you possibly can whenever you're going through and picking out apples and oranges, it is a lot faster. So I just work at the ends and I work towards the middle. So the most I'm going to end up going through every element in this array is just whatever the length is divided by 2. Just going to work towards the middle, hopefully. In this particular instance, I'm sure I could rewrite this and make it more efficient. No comment. Once again, terrible technical interviews, but this solved the problem. And it was fast enough for leak code to pass me. I loop through the front and the end, see if it checks. If none of them ever check, I return false. And if those don't ever return false, I just return true. For odd, I do something very similar. I work up to that middle, and I work towards the middle. And then if they're the same, because I have to include that middle character this time, right? I can't just stop one shy. I have to include the middle character for both sides of the string. Mind blown. This is just a interesting contrived example for how you would solve it if you approach this problem for the very first time. It's not the only way to solve the problem. It's just the way I came up with it the first time. And it's using a for loop, very first thing you're ever going to use. I'm now going to show you the way I solve this particular problem using slightly more advanced, I think less verbose syntax. I'll just do check even. That way I don't have to walk through the check odd code. All right, so this is already, it's a lot smaller, that's for sure. I use the terms first and second. So in the previous example, we looped over an array of characters and came to the middle. In this example, I literally cut the string out up to the middle, and I cut the string out towards the end, flipped the one at the end, and then checked if they were the same. It's a little bit more, I pulled a weird tool out of my bag that I happen to know using slice. If you don't know slice, use a for loop. You don't need to understand or know it to begin with to solve the problem. For loops will work. I happen to use slice every now and then, especially using some front-end frameworks. I pulled that tool out of my bag and I solved the problem. I think it's a lot less verbose. I think it's a lot more kind of clear what I'm doing, but I'm sure there's 100 other ways to solve this particular problem. And make sure it actually works. So let's go ahead and, so that was for check even. So, right, we're gonna tack and then cat, 6 letters, so 6 is even, and this is a palindrome, so this should return true. And if it doesn't, it's broken, I won't solve it here, and you guys can laugh at me and be like, man, we should have got a different speaker. So this should not return true, this should return false. It is not correct. Okay, and also if I add a capital letter in the beginning because I lowercase it to begin with, this should return true. It should not care if it's uppercase or lowercase. Woo, I didn't, woo. Live code always goes wrong, by the way, so if you see people come up here in live code and nothing goes wrong, standing ovation. That's all I'm saying. All right, so we're nearing the end of this talk. The big things I want to drive home is that math, for the most part, especially higher level concepts, aren't particularly used in real world scenarios. It definitely helps to have solved many math problems, but it's not the number one skill. The number one skill is your knowledge of a programming language and just kind of your time doing the thing, right? The more you do something, the better you get at it by default. The more you're around the environment in which people are doing that, the better you're going to get. You don't have to have all these fancy tools in your backlog of tools or your backlog of experience to be able to solve these problems. You can use the most basic generic tools you can, and that solution is still 100% valid. It is not the wrong solution. It may not be the absolute zenith of solutions. It is still a valid solution, and it works just fine. I named this talk Think Like a Programmer after a book that I got after I failed that first coding interview called Think Like a Programmer. I think I paid like $30 for it. It was worth every penny for sure. I had a real issue with, in myself, kind of separating the contrived examples where they're just solve some random brain teaser versus real world scenarios because they're so vastly different. And because the real world is the world we live in, they tend to be easier to solve. But there's still value in figuring out kind of the tools of the trade and solving these problems in different ways so that whenever you get painted into a corner where you only can use a particular tool, you have it available. And when in doubt, you should always try to solve it yourself. Second step is do some research on the internet, Stack Overflow, Google. And lastly, come and ask another developer if you can. If you don't have one available, we have a whole Slack channel full of developers. You are more than welcome to ask them anything you would like. If you provide context to the question, it helps them. I guarantee, I don't know if I've seen a kind of rude answer ever on any of the forums in Techlahoma for the most part. They're very welcoming because we've all been junior developers and we know the value of kind of bouncing questions off of our seniors because we don't have the backlog of experience needed to solve a particular problem. So with that particular segment down, I'm going to give away 3 books today. Give me just one moment. I'm going to bring them up here and then show them off. And I'm going to do them first come, first serve. Oh, thank you, Kimberly. So because I've had these books for several years, I kind of know them by now. They're not as valuable to me as they would be for somebody else just getting started or someone wanting to problem solve using different tools. The first one is the one for the title program. It's called Think Like a Programmer. This is creative problem solving. There is code in this, but for the most part, they're story examples. So they try to get you to word the problems into small stories to help you figure out the answer in a more material way. This is an extremely helpful book. It was recommended to me in 2014. I purchased it, set on my shelf until I failed that technical interview, and then it came off of my shelf for about 8 months or so, and I try to go through each one of these problems in this book in particular up until late 2015, early 2016. It is extremely valuable. For the most part, if you ask people what's the best book for, well, I should say, most of the people I ask what's the best book to learn how to, solve problems in programming, they recommend this book. So this one is by Anton Sproul, and it's on Amazon right now for $24.99. So if you don't get this today, it's okay. You can go buy it. It's $24.99. Lots of expert excerpts are available online for free as well. So if there's a particular problem, I think they do the duck, the seed, and the fox problem, which is a very interesting. I would never be able to solve that with code. Maybe I would. But anyways, that's another kind of contrived example that's very interesting. So who would like this book? First person to claim it. Second row? Huh? Here you go. All right. No, it's all yours. It's all yours. Not a problem. We'll do, this book right here is the one that I was told was like super important. I thought this book was great, but I got it when I was already a mid-level developer or so it wasn't super valuable to me. And it's also jQuery, which I use every now and then, but now I'm mostly using, oh boy, you're already raising your hand. I'm not doing that one yet. You jumped the gun. You jumped the gun. See, I hadn't defined the rules of the problem, so she was solving it very quickly. The next one I'm going to give is a particular book whenever I was heavy to C#, and I thought certifications were the way to go, which they have value. They didn't happen to help me in particular. I went to the Microsoft store, and I bought a book on programming in HTML5, JavaScript, and CSS3. This book is kind of a combination. It's not just JavaScript. It also involves HTML and CSS. And if you're just getting started, it's also HTML5 too. If you're just getting started in programming, this book is pretty good. It's going to help kind of answer some of the questions about attributes you may not be aware of. And if you want to kind of get the more rote memorization part of it, this definitely has that. It even has practice quizzes in it. So, who would like this book? You again? And this one, I think this is, so for those that don't know, well, I guess nobody knows. I was in sales for a long time. I self-taught myself to program while I was doing sales. So in between my downtime between phone calls, I would go on free Code Camp, and this is like when it first came out, and I would program. Most of the things, that book and that book in particular, actually paid for with promotional points I got from being really good at sales. So I didn't have to pay any cash for them. And I am extremely frugal. I do not like spending cash if I can get it for free or with something I get for free, so to speak. This book I paid for with cash. It was recommended several times. I know whenever I said I was going to be giving away this book, my good friend that actually got me started for the most part in programming was my first lead developer, Clayton Flesher, said this book was fantastic, and I definitely agree. This one is JavaScript and jQuery, interactive front-end web development. This one is good for those that are really wanting to get into front-end development and do more advanced things like accordions and drop-downs, and then user interface, interactive design and stuff. This one is very valuable for that. So, who would like this book? Oh, now it's quiet. Now? Are you sure? You already have one. Here you go. All right. Thank you very much for coming today. I hope none of you are intimidated by any of the topics I covered, and I hope I've at least motivated you to not be scared to try to tackle some of these problems. If you have any questions, comments, or concerns, shoot me a Slack message. I will do my best to respond. I'm Whoop, Twitch. What did he say? Or she? Space and time complexity. Okay. So I was asked a question on Twitch. Do I get many questions about space and time complexity? Most of the positions I get interviewed for are going to be full stack JavaScript development, and space and time complexity are super important. If you're interviewing for companies that really value space and time complexity, like Google and YouTube and Twitter, I work for a lot of companies that need really good developers to do really complex interactive changes of the front end, and also want really efficient APIs on the back end that aren't delivering super complex videos or search algorithms for millions and millions of websites. So the short answer would be no. I personally do not get asked a lot of time and complexity problems, and that's not because they aren't out there. It's just because I am siloed into a particular portion of my career where I choose interviews that do not have those. They're not my forte, but they definitely are out there. Big O notation, for instance, knowing that a hash map is, I think, O(n) of 1, something like the O of 1, it's very, very fast. And knowing that an array, when you're looping over all the values, is equal to the amount of values you have to loop over, which is like n or n plus 1. That's an important concept to know, but I don't get asked a lot of those questions, mostly because I don't choose to take those kinds of interviews. I would probably fail. Don't have a lot of practice in it in my daily life. Any other questions before we turn this off? No? Cool. I think for the next meetup, I'm going to allow Kimberly to talk and possibly give out a 30-minute pair coding exercise where I will jump on with you and pair code either in person or via a code pairing session online, and we can work through some problems or something like that. I recently did it. They found immense value in it, so I'm thinking about offering that. I'll have Kimberly just hand that out somehow, some way. Thank you very much.